Yeah, I'm ready.
Uh, okay, so we started this to review the Mentor Core, right?
Yep.
We went straight to this fixed price market maker. Uh, and we found that the swap function, let me let me just check my notes. Okay, yep. We found this swap function was actually kind of different than the uni v2 one, right?
Yep.
And the different thing was this rate numerator and the rate denominator.
Mm-hmm.
So they do this because they use an oracle to fetch the price of the pool instead of just getting the ratio
Okay.
between the two tokens. Uh, they get it from. Okay, splitting the screen would be easier. They get it from this function
It's the same.
which calls the oracle adapter, which
Mm-hmm.
we already went through, right?
Yep. Yep.
And I guess your question was, can these two be manipulated? I guess they can be with the medians again, but I also guess that this will be again the same root cause,
Yes.
right?
Yes. Yes.
So we can say this is like we can just leave it, right?
Yes.
Um, Another thing which I found interesting, and I guess it's also new. It's not from Uniswap, not sure. Is this calculation here?
Can you go inside this function?
Yep. What they do is basically just turn one of the tokens.
Yep. Yep.
Yeah, you got it right.
Yeah. Yeah.
They
It's.
just add it to token one.
Mm-hmm.
To get the reserve value of the whole pool, I guess. That's how I understand it.
So they enforce that this reserve value increases probably.
Yep, yep. But this is not checked anywhere, and it's not used anywhere.
It's not in
And I
what
couldn't.
swap check. What does swap check do? Yep, it's over there. New reserve value.
Oh yes, yes,
They
yes.
check.
I actually haven't. W- I didn't go through this function. I got stuck here on the trading limits.
Let
Yeah,
me
so
let me
that
just go.
that's kind of in the future.
But can we go there? I'm curious. Can we say can we check this swap check?
Swap check.
Yeah. Yeah. So they get new reserve. But so they update this storage. Can you go back again? So they update the storage before swap check. The reserve storage.
Yeah, that's what I got curious about
Yes, they
also
do.
because
They do. In update. Yeah. Yeah.
I went through the functions where update is called again, and pretty much it's called at the end of each function. Only here there's a swap check, and on the I think the rebalancing thing has another check. Yep, and the rebalancing thing is also a new thing, right?
Yeah. Okay. So let's show me what this update looks like.
It's uh it's very
No,
simple.
it's yeah. It keeps going to the wrong.
Yeah, yeah, yeah.
Okay. Cool. It's correct. Now go back, please. Let's go to the swap check. No. I just want to see how they enforce. So they get the new reserve value. and then they have expected amount 0. Interesting. So based on this rate, they know, like if you take out amount 0, then they calculate. I'm still looking at the 8 to 8 line, like the expected amounts. So from what I can see, they get the amount 1 out, and then they convert to amount 0, right? So they're like, what's the equivalent if they want to take it?
Yes. Using the
Mm-hmm.
adapter.
Yes. They do the same for the other one. They have the fees, total fees, protocol fee, okay, and then they take the fee, basis point, total fee minus expected. So they take the fee on the amount in. I think that's standard, if I'm not
Can I check
mistaken.
this function?
Yeah, they just switch to the other token, right?
Yeah, I was wondering why are they calculating fees here?
So they charge. Look, they charge the fee. So they get fee 0 and fee 1 from.
Yep.
Uh, yeah, they do this math, like this math. Can I don't think I can. 0.9. Okay, I think I know where this like where it comes from, because like if the total fee is 10%, right? And
Yeah, yeah. Total fee can be max 1%.
okay, 1% doesn't matter.
Yep.
Um, so the fee is the amount in divided by 0.99. Yeah, I think this is correct. Minus the expected. This can be simplified. Like if you simplify this expression, right? If you expected amount 0 in, if you can simplify it. Like if you multiply and divide by the denominator, right?
Yep.
What does it? What does it? So it's minus. So it's like, okay. So it boils down to expected amount 0 times total fee, basically. I don't know why they do this expression, right? Can you ask the LLM? The LLMs are really good at doing this. Just ask it, like, simplify this. I think it boils down to expected amount times fee, if I'm not mistaken.
This way, right?
Yeah.
I I was wondering why are they calculating them like because they already calculate and send them before the swap check, or just is just a check. That's why I can't understand.
Yeah. Can you show the? Ah, it's still thinking. Okay. I don't use.
Yeah, I still thinking.
I use the.
But I mean, right before the swap check, they did calculate the fee and transfer it. That's in the swap function.
Yeah. Like, okay, so it simplifies to what?
This is the simplified one. Okay, let's do it that way.
Yeah, exactly. Okay. Yeah, this is
Which
correct. This is like Uniswap does. It's the same. Yeah, yeah,
is it?
yeah. Basically, because or is it not? No, I think this is not actually because this. I think the amount in. I think Uniswap applies this, but to amount out, not to amount in. What do they say in the? Yeah, it shows some examples. Let's see what the fuck they say. But maybe it doesn't matter if they don't have slippage. Yeah, it's probably because of that.
Because they don't have slippage, right?
Yeah, they just use the rate.
Yep.
Yes, fee times fee rate. Yeah. Yeah, but like this. Well, okay. Go through the number. Through the numbers. Let me check. No, no. In the LLM, it shows some numbers. Okay. Let's see. You want $100. How much fees charge? Yeah. The thing is that. Yeah, but look, this formula. You want $100 of tokens, but
Yep.
that's the amount out, right? And this is the amount in. Can you see? It's not. This is not. Doesn't seem correct. I think because this is the amount
The
in.
mountain.
Like
Yep.
usually, yeah. Usually the fee is a percentage of the amount in.
They they come from this function.
Yeah, I mean this looks like it's switched. I don't know why they divide by one minus fee here. That's what. Oh no no no! It's correct. Yeah, because it's based on the amount out. Yeah yeah, or not, or is it not? Yeah. Oh okay. Yeah yeah, I think so. Because this expected amount in comes just from the amount out. Yeah, you need to check this fees. It's hard to understand it like on the spot. Would need to think more about it if the fee charge is correct. But
Okay.
yeah, basically if you swap 100 and the fee is like 1%, right? You should
Yep.
get you should get 99, right?
Yes.
That's what I'm trying to check. And I'm not sure if you get 99 or you get um 100 minus 100 divided by 0.99, which is not 99, it's different. Yeah, like yeah, that's does that make sense? You need to check because right now it looks like what you get is
So I just need to play with the numbers here.
yeah.
It also looks there will be some kind of could be some kind of rounding by this number. I mean, I'm just guessing here, but
Uh, yeah, maybe. I don't know. Okay, then let's continue. So yeah,
okay, we were here, right?
yes.
Um, we needed to check this function also, but I think, yeah, I mean, it's pretty simple. I don't think like a fee of zero will just return, not screw anything here. Um, this denominator
Yeah.
10,000.
So they
The
it's
fee, I
it looks this looks correct. So they apply the fee to the amount in, right? So it's
yeah,
correct. Okay. Yeah, this looks good.
and that's that where like where I got not stuck, but this trading
Let me
limit.
just try to understand. Like, did you try to understand the swap data amount zero in? Where does it
Oh,
go? Yeah, like this
this
line.
these things.
No. Like the swap data amount zero in. Like, how is it calculated? Yeah,
You
this.
mean these calculations? These
Yes,
two.
yes, yes, yes.
Okay, so they come from. Wait, you want me to like explain what these do?
Yeah, just to see if it's correct.
So they're trying to calculate how much the user added to the pool, right?
Yes, but like the math.
So balance zero is a balance of the tokens. They check if it's higher or lower than the amount after the user takes
Yeah,
tokens. I think it's implemented right because uh, if these two return zero, this will just revert. So the users should return the right amount or more.
yeah,
Isn't
I
this
know.
implemented because of the hook with the flash swaps?
Yeah, I just wanted to see if it's correct. I think it looks like it's the same logic as Uniswap.
Yeah, looks correct to me also.
Can you wait? I can open it here. It's easier. Let me just check the Uniswap v2 code. It should be the same. I don't remember this part exactly. Let's see.
Is there a room um, for for exploit with these hooks? and these flash swaps and
I mean,
these things.
this
Because I'm not so familiar with hooks.
this hook is just a like it's like okay. So all this AMM has the non-reentrant modifier, I think, right? So
Yep.
it's impossible to damage the AMM. But if anything depends,
But what? Sorry.
there may be something that depends on the AMM external. Yeah. Okay. So this is the Uniswap logic. It's the same. They do the same logic.
Okay.
So you can you can assume it's correct. But like yeah, I mean yeah. Okay. So they get the amount zero of each token. They transfer the So the protocol fee, so they transfer the protocol fee and then they check the swap. Interesting.
Yeah, but before checking the swap, they update.
Oh, so they update. Okay, but like this protocol,
I guess they needed to update because of this transfer of the protocol fee.
but this protocol fee is
That
not.
that that's my guess.
This protocol fee is just is not the LP fee, right? Can you open this again just to check? Yeah, this is just the protocol fee. Okay, so now go back. So okay, then they update. They update so the values. Okay, so the reserve doesn't have the fees anymore. So let's go to swap check now. Yeah, this reserve doesn't have the. But there's an LP fee. Oh my god. What the fuck? So they get rid
Yeah,
of the protocol fee, update the reserves, and but they don't charge the LP fee, which is odd. What?
why would they charge the OP fee? Shouldn't it be charged on minting and burning? I don't know. The OP fee.
It's on line 851. You can see there at the bottom. So it's the initial reserve value plus total fee in token 1.
Yeah. Why are they calculating it if they are not going to transfer it?
No, it's because they increase. So this reserve value, the expected reserve value is the K basically of the Uniswap. So if this increases, LP uh, users increase also. You know that's how the fee is charged. It's like automatically. So that's how. Hey,
So the new reserve value should be higher than the expected reserve value.
yes, that's how they accumulate fees. That's how they accumulate fees. So yeah, we need to make sure this total fee in token one is correct. But it's weird because the new reserve value already removed protocol fee. Oh my god. Yeah.
Okay, so basically this function needs
Yeah.
some brainstorming.
Yeah, because so you need to plug some numbers basically. But like because you get the expected amount. The new reserve value doesn't have the protocol fees. Can you just write some numbers on this? Can you open the LLM just to write the numbers so it checks for us? So just let's just say let's go through one example of this. Okay, let's say you have initial is 1000 of each. No, but write like just the math numbers. Just write like token 0 equals 1. Can you make new lines here? I don't know.
Yep.
Okay, so write token 0 equals reserve 0 equals 1000. Reserve 1 equals 1000 as well. Okay, so now let's go through the swap function again.
Uh,
I,
you mean manual?
yes, but the swap, yeah, the swap. So let's just check again how this is calculated. So initial reserve value is go check. Let's say the price is 1 to 1. Open total value in token one scaled
Wait, uh,
in the middle. Yes, open this function. Total token zero value in token one. Amount zero decimal zero 1 to 1. Okay, let's just say oh because wait, this is interesting. Yeah, this is not Uniswap, not Uniswap. This is not x times y equals k. This is x plus y equals k. You know, because they are not multiplying the reserve 0 times the reserve 1. They are adding them. You know. So the invariant is not x y equals k. It's x plus y equals k. Right?
yep. Okay.
Okay, so right there, k equals 2000. Okay, now let's go back to swap. Okay, so you removed, you have to, yeah, but like you have to calculate beforehand how much you need to pay back, I think. Yeah, you need to calculate how much you need to pay back.
I'm I'm trying to keep up with you, but like I got lost here, if I
Where?
need to be honest.
Where?
Um, like oh, okay, we are doing this calculation here,
Yeah.
To find out, wait, my mouse died again. Okay. Uh, we are doing it to find out if
The fees are correct, basically. Yes.
these are right. Yes, if these are correct. So in order to find out, we need to. Why did we went back to the swap function?
Because I wanted to plug some numbers to see. It's easier to check. It's easier to check.
Okay, so what do we do now?
Yes, that's what I'm saying, because it doesn't tell you how much, like if you take token 0 out, it doesn't tell you how much token 1 you need to give, right, to amount in. It doesn't tell you because you need to know so the final invariant is bigger, you know. Right? Do you understand how it works, the logic?
Uh, are you here?
Yes, yes. So the logic.
Can you hear me?
Yep, yep.
Because I can't.
Yeah, yeah, yeah. I'm here.
Okay, I think I hear now,
Okay, okay, cool. So what
but
I'm
I
saying
hear
is.
in pieces again. Oh, yep. I don't hear you.
Okay, okay. I mean, that's fine. Let's